Hello everyone. In this tutorial, I am going to show you how to solve trigonometric equations using algebraic substitution. And we have a very simple equation here, square root of 3 sine x plus 3 cosine x equal to 0. We know that traditionally we can take 3 cosine x to the other side, divide both sides by cosine x, divide both sides by 3 root 3, just to have a tangent x here equal to negative 3 divided by root 3. Then we take tangent inverse of both sides, which is very simple. But sometimes you may encounter a very complicated trigonometric equation. So this is the purpose. The purpose is not to solve it directly using traditional way, rather using substitution. What you should remember is if you have sine x, you can confidently replace it with 2t divided by 1 plus t squared. And if it is cosine x, you can replace it with 1 minus t squared divided by 1 plus t squared. Then you solve the equation in terms of t. Then in the end, you should know that t is equal to tan of x divided by 2. This is what you should know. All right, let's get started. Seeing sine x here, I will replace it with this one. So we have the whole of this times root 3, which is going to give us 2 root 3t, right? Because we have 2 here, we have root 3 here. If you multiply them, you get 2 root 3, then we still have t. Then remember, we have divide by 1 plus t squared. 1 plus t squared plus. Seeing cosine x, I'm going to replace it with this one, but the 3 will have to multiply the numerator. 3 times 1 is 3, minus 3 times t squared, 3t squared, divide by 1 plus t squared, everything equal to 0. You can see the denominators are exactly the same, so therefore we can confidently add the numerators. But I would like to start with the leading term here, which has a power of 2. That will give us negative 3t squared. Then we have this term here plus 2 root 3t, then plus 3. The whole of this divide by 1 plus t squared. This is equal to 0. Now we have a rational expression equal to 0. You know that the denominator cannot be 0, and hence we have to set the numerator to be equal to 0. But let me multiply every single term by a negative sign just to have 3t squared minus 2 root 3t, then minus 3. This is equal to 0. Now we have a quadratic equation. I think we can solve this using general formula. Remember that t will now be equal to minus b. My b is the coefficient of t. If you minus it, it becomes positive. So this is 2 root 3 plus or minus square root of b squared. If you take this, you square that, negative 2 squared will give us 4 times. Root 3 squared will give us 3. So the whole of this will be 12. Minus 4ac. 4a is 3, c is what? Negative 3. But remember, this is minus 4ac. This minus and this minus will give us what? Plus. 3 times 3, 9. And 9 times 4 is 36. So this becomes plus because we have minus here, and this constant minus, we have plus 36. The whole of this divide by 2a, and a is the leading coefficient. 2 times 3 is 6. All right, I think I can move to the other side. Let me see here, 12 plus 36, that will give us 48. And square root of 48 is 4 root 3, yes. So this is 2 root 3 plus 4 root 3, plus or minus, right? Plus or minus 4 root 3 divided by 6. So we have two values of t here. Let me take the first one. The first one I'm going to use plus. So since the sorts are the same, I can add their coefficients. 2 plus 4 is 6, divided by 6 is 1, and we still have root 30. So the first one is root 30. And the second one, we minus. 2 minus 4 is negative 2. And negative 2 divided by 6 will give us negative 1 over 30. Negative 1 over 30 times root 30 is just negative root 30 divided by 30. So we have two values of t, but remember that I told you t is equal to tan x divided by 2. Therefore, tan x divided by 2 is either equal to root 30 or tan x divided by 2 is equal to negative root 30 divided by 30. So we are going to solve these two equations separately. If you take tan inverse of both sides from here, you have x divided by 2 to be equal to tan inverse of root 30 is pi divided by 30. Yes, but remember that tangent is periodic in every given pi, so you add multiples of pi. Then you multiply both sides by 2. You have x equal to 2 pi divided by 30 plus 2 pi k. We are done with the first equation. Then we move to the other one. If you take tan inverse of both sides, you have x divided by 2 to be equal to tan inverse of this will be negative pi divided by 6. Add multiples of pi, then you multiply both sides by 2. So x here will be equal to 2 times this. 2 will go into 6 exactly 3 times, so we have negative pi over 30 plus multiples of 2 pi. And you can take the smallest positive angle here by adding 2 pi, and that will give us 5 pi over 30. So x is equal to 5 pi over 30 plus 2 pi k, for which k is an integer. But one thing you should know is that from 2 pi over 30 to 5 pi over 30 is pi, because once you add pi here, it will take you to this. Add pi to this, it will take you back to a coterminal angle of 2 pi over 30. And therefore, you can take the union, right? So x finally will be equal to just 2 pi over 30 plus multiples of pi, not 2 pi anymore. Because from this, I know that if I add pi, if you want, you can try it. 2 pi over 30 plus pi, but it is the same thing as 3 pi over 30, right? Yeah, I just rationalize it to make it the same denominators. 2 plus 3 is 5. So if you add pi here, it will take you to this. Add pi is just a diameter. They are on the straight line. One in the second quadrant and one in the fourth quadrant. So we have a diameter. So if you take this, you continue adding pi, you have infinitely many solutions. And hence, this is the solution to this problem. But if you like, this is just the purpose of this tutorial, to use trigonometric algebraic substitution. But if you like, you can divide every single term by cosine x, take other terms to the left hand side, leaving tangent x to the left, take tangent inverse of both sides. You will surely get this solution. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.